I'm going to start a very important chapter of class 10th NCERT, that is metals and non-metals of chemistry, right? You must have learned in class 9th what are elements, and you know there are 118 elements present on earth. 118 elements. Out of them, 90 are naturally occurring. It means some of the elements are also human made, right? If we talk about how many of them are metals and how many of them are non-metals, then metals are 80. Out of 118 elements, there are 80 metals and 22 non-metals, right? 80 metals, there are so many metals on the earth, but still ocean, earth and air, they are mostly constituent of non-metals. For example, in earth crust, oxygen is almost 50%, and second most element that we see on earth crust is silicon. Writing it here, oxygen, right? And then the second most found on earth crust, that is it is 26% silicon. In ocean, if I see, hydrogen and oxygen are the most abundant, and earth crust are, if you see, air also, air has 70, almost 78% nitrogen, and then rest is oxygen. So these are the metals and non-metals. But if someone asks you what are metals and what are non-metals, how will you define them? So the simple definition will be we will get its definition from the knowledge we have from the previous classes, right? Let's say now we have a element called sodium. How many electrons does it have? It has 11 electrons. You know how to fill them? Let's just fill them: K shell, L shell and M shell. K shell must contain 2 electrons, then 8 electrons, and then how many are left? 8 plus 2, 10, 11 minus 10, 1. Now you know that if it needs stability, it must have at least 11, or it must have at least 8 electrons in its shell, right? In the last shell. But here you can see it is only 1. So it can take 7 electrons from someone else. No, it is not possible. Who will give 7 electrons? No. So it will lose 1 electron from the last shell. Now the last shell has its 8 electron, it will get stable, right? So it is, what is it doing? It is losing electron. In the same way, if we do it for oxygen, oxygen has 8 electrons, total 8 electrons. So we are going to fill them in a shell. First 2, then 8, then 6, and then we don't need here the shell. Now to get the stability, it also needs 8 electron in its last shell, but it has only 6. So what will it do? It will take 2 electrons and will become 8 to get stable. So there are 2 different things happening in the elements. One, they are losing electrons. Sodium is losing electron and oxygen is gaining electrons. And this is the major difference between a metal and a non-metal. Now someone asks you what are metals. The metals are the elements that loses electrons from its outermost shell and form a electropositive ion. I'm writing it here, electropositive ion. because the board is small, so I'm not writing the whole definition here. So, right? So what are metals? Metals are the elements that lose electrons from its outer shell and form electropositive ion. Now Na will become Na plus after losing one electron, so we will put 1 plus. Now what are non-metals? The non-metals are the elements that gain electrons to get the stability and form electronegative ions. Hope this is clear. So what will it form? It will form O2 minus because it gained 2 electrons. So here we are putting 2 minus, right? So this is the major difference between a metal and a non-metal. Metals lose electrons, oxygen gain electrons. Now in this chapter, we will learn about what are the differences between metals and non-metals on the basis of their physical properties and chemical properties. Physical properties of metals and non-metals. So I'm just making a table here. Metals and non-metals. And the property. I hope I am not out of the frame. So first property is, what is the first property? First property is electricity conduction. Let's start with electricity conduction. Metals can conduct electricity but non-metals cannot. Then second is lustrous. Luster means the shine. When we cut the metal like transversal cut, then you will find metals lustrous from inside, shiny from inside, but non-metals are not. Some exceptions are there. For example, iodine and graphite is also lustrous. These are the exceptions. Right? Third, malleable. Malleable means that the substance can be converted into thin sheets. Malleable, what is malleable? Malleable means the property by which a substance can be converted into thin sheets. So malleable, metals are malleable. They can be converted into thin sheets. You must have seen a thin sheet of silver on your sweets, and gold foils are also there, and then aluminium foil that we use daily in our kitchen. Malleable, metals are malleable. They can be converted into thin sheets, but non-metals can not. Fourth, ductile. Ductile means it is the property by which a metal can be converted, any substance can be converted into thin wires, can be drawn into wires. So ductile. Metals are ductile. We can make wires of metals, but we cannot make wires of non-metals. Now non-metals, there is an exception also. We cannot make wires, but we can make fibers of carbon. So I am writing exception here. Carbon fibers are there, but they are not wires actually, but they can be converted into thin fibers. So these are the four properties: electricity conduction, lustrous, malleable, ductile, ductility you can say. Now what I am doing, I am just rubbing them. Next property will be thermal conductivity. Thermal conductivity. Metals can conduct heat, but non-metals can not. Metals cannot conduct heat. Then sixth property will be boiling, melting, and boiling point. Boiling and melting point. Generally, metals have high melting and boiling point. High melting and boiling point, and they have low melting and boiling point. Right? Then any other? Then there is hardness. Hardness is very important. Now hardness, metals are generally hard, non-metals are generally soft. If we talk about state also, metals are generally hard, except mercury. Mercury is in liquid. But if we talk about non-metals are present in all three forms. They can be gaseous, they can be liquid, or they can be into hard form, into solid form, right? Like bromine is present in liquid state. Bromine is a non-metal. Hardness, metals are hard, non-metals are generally soft, but here exceptions are also there. First of all, mercury is not because it is liquid, it is not hard. Then there is potassium and sodium. Then there are potassium and sodium. They can be cut with a knife. They are very soft that we can cut them with a knife. If we talk about density, the next should be density. Then they are generally have high density, they generally have low density, right? So these are the physical properties of metals and non-metals. Now the board is very small, so I cannot write so many of exceptions there. Some exceptions are also there, which is very important. They are present in NCERT, but most of them we have done. Some are left. So these are the physical properties, and one of the question in MCQ you will find from here in your board exam. So you must learn all the exceptions. That is very easy thing you must have done in class from 6th to 8th you have learned. But exceptions are very important for your board exams. Now we will talk about the chemical properties. We can differentiate metals and non-metals into by their chemical properties, how they react with oxygen, how they react with acids and base, how they react with water. They react differently. So we can say that metals and non-metals can be distinguished by their chemical properties also. Today we are going to do just one property, that is when they react with oxygen. The reaction of metals and non-metals with oxygen. Right? Reaction of metals and non-metals with oxygen. Magnesium, when reacts with oxygen gas, forms magnesium oxide. Right? Sodium, when react with oxygen, forms sodium oxide. So when metals react with metals react with oxygen, they form their oxides, and their oxides when dissolved in water, form metal hydroxides. They form metal hydroxides. What are metal hydroxides? They are basic in nature. They are basic. So we can say that magnesium, what we have learned, all the metals when react with oxygen forms their metal oxides, and when metal oxides are reacted with water, they form metal hydroxide. So finally we can say that magnesium oxides are, sorry, metal oxides are basic in nature because they form hydroxides. They form hydroxides. Some of them also form alkaline solution. Alkaline solution means this. Na when reacts with water forms NaOH, sodium hydroxide. Right? I'm just rubbing it and writing a equation. Metals plus metal plus oxygen forms metal oxide. And metal oxides are basic in nature. Basic in nature. That you should know. They are basic in nature. But some of them are amphoteric. Now what are amphoteric? Some of them are amphoteric. I am writing the term here. Some of them are amphoteric. Now what are amphoteric oxides? Amphoteric oxide means that when metal oxides are basic in nature, but when these oxides react with acid, that time they will act as the base, and when they will react with acid, so they will act like a base. Let's see, just amphoteric. Al2O3 is an example. It is an amphoteric oxide. So when I reacted with HCl, then it will act as a base because it is acid. But when I reacted with NaOH, then it will act as an acid. Got it? Got my point? So amphoteric oxides are the oxides which are doable. Like with acids, they act like base, and with base, they act like acids. Right? So Al2O3 plus HCl will give AlCl3 plus H2O. Right? This is a kind of neutralization reaction where the salt and water is formed. So when acid and base reacts, they form salt and water. Very simple. And in this equation, salt and water will form. So it will also form Na, AlO2 plus H2O. This is called sodium aluminate. This is called sodium aluminate. It is a salt and water. So what we have learned? We have learned about physical properties of metals and non-metals. We learned about what are metals, which one lose electron, which one gain electron. Then physical properties and chemical property. We have done only one chemical property, that is reaction of metals with their with oxygen. And the very important part was amphoteric oxides. Amphoteric oxide is something that always comes in the question paper. It has also come this time. What are amphoteric oxides? These are the oxides of metals that are doable, or what we can say that when they react with acid, they act as base, and when they react with base, they act as acid. right? And they form salt and water, like neutralization reaction. This is all for today. Thank you.